Thank you very much, and thank you very much for having me here. It's a real pleasure and honor, and I truly enjoy our work with the Task Force of Academia European on Sustainability. And what I'm going to show today is partly relevant to that. So I've been always interested in interdisciplinarity. Officially, my background is mathematical economics and statistics. This is where I've done my PhD on. But I've been always interested in the osmosis of disciplines for solving real-world problems, and for science to have an impact on caring, sustaining, securing the welfare of people. So today I'm going to be talking about integrated climate modeling, but Kathleen told me to give special emphasis to food systems and land use. But let me first introduce who we are. So since 1997, when I was in Cambridge as a lecturer, but back then just finished my PhD there, I've put together this Alliance of Excellence for Research and Innovation on IFORIA. And this is an alliance of excellence putting together the research and innovation centers and institutions that I am affiliated with, some innovation accelerators that I chair or co-chair, currently incubating 350 spin-offs and startups, mainly focusing on climate adaptation, sustainable shipping and ports, and sustainable marine environments, all actions in the marine space, shipping, again, ports, energy production from the sea, sustainable ecosystem services, tourism, coastal and inland interaction, and so on. And then I also work closely with science policy networks. I am the chair of the SDSN Global Climate Hub, which is where I'm going to be focusing today, showing the work of this element. SDSN is a global network of universities and research institutions under the auspices of the General Secretary of the UN, with more than 2,000 institutional members, focused on facilitating the implementation of the SDGs and the Paris Agreement. So I lead the European hub there with 900 universities, and I also lead the Global Climate Hub, which is about, and I'm going to introduce that, deriving country-specific decarbonization and climate adaptation pathways in a very holistic, integrated framework. And of course, I work with various academies. I'm the president of the World Council of Environmental and Resource Economies. These are, environmental and resource economies are the most interdisciplinary economies because they have to understand the natural systems and integrate them in our optimization exercises. So by definition, we have to work with others. And then all the different academies that I am involved in leading the Sustainability Task Force. So our focus, we are a big group of scientists, more than 215 now, working in many countries, 120 countries with case studies, and over the years being quite successful in attracting funding. And when I talk about projects, these are projects that I am the PI. These are not projects of the institutions. These are projects of IFORIA. So our focuses is divided into thematic area, but our overall focus is to develop models that give you the sustainable interaction between nature, economy, and society, and can lead the implementation of these sustainability pathways on the ground for impact. So our work is quite detailed, and we have a policy and implementation focus in addition to the development of the modeling. So thematic areas, climate neutrality and resilience, water, food, energy nexus, and the land use and land use change and forestry, oceans and seas, socioeconomic, financial, and behavioral economics, innovation, acceleration, education, upskilling, reskilling. Okay, our general framework is that we start from the policy targets and commitments, which we accept as the destination where we want to go. Of course, this can be revised and refined based on science results, but at the moment, what do we have? Well, the history of sustainability, of course, sustainability did not start in 2015. The sustainability concept entered the policy agenda in the 70s. But a good summary of what we have now on the ground is the SDGs, 17 Sustainable Development Goals, very holistic framework, 169 targets, about 300 indicators measuring them, the Paris Agreement. Then if we stay in Europe, we have the European Green Deal. So we have this big deal with 150 regulations that have been designed and voted for since 2020. Basically, it was announced late 2019. Then came the COVID, early January next year. And this European Green Deal that mainly has 4 axes: climate neutrality 2050, leave no one behind, reduce pollution, and clean tech leadership for European companies. And all these axes have been translated into 150 laws and regulations. I'm not going to go through all of them now because I want to show you other things, but these are the major policies. Next Generation EU added to the 1 trillion that was there to support the implementation of the European Green Deal, another 750 billion so that we recover from COVID in a sustainable way. And then, of course, we have the climate law, the taxonomy, which is how we direct financial resources to sustainability, the Fit for 55, reduce climate emissions by 55% compared to what we have in 1990 by 2030, and then become climate neutral by 2050. And then we had Repower EU, given the war in Ukraine, to disengage from Russian fossil fuel, digital policies and industrial policies that are relevant. Then we had the alignment of the common agriculture policy with the European Green Deal in 2023. 2024, we had the nature restoration law, but also the Draghi report focusing on sustainability, but saying that we need to engage with competitiveness in order to be able to transform to sustainable pathways, and it's true. And then in 2025, we have the Omnibus, which basically said, make sustainability and European Green Deal legal framework more simple, more consistent. Don't drive people crazy. Oh, God, thank you. Don't drive people crazy, just be efficient in achieving what you need. And I just want to say that in one of our deep neural network analysis, we identify a very close connection between the SDGs and the European Green Deal, laws and regulations, and this is good news because it means that the SDG spirit intrudes the different regional policy framework. And this is not true just for the European one, it's true for others as well, other regions as well. So we have our targets, and then what we do is that we measure where we are. So we have the Sustainable Development Report of SDSN. I lead the European report, but of course I participated in the global report, and this is measuring where we are with regards to achieving the goals. We have 300 indicators for the 169 targets, understanding the trade-offs and synergies between the targets that make up the 17 SDGs. And you see that we have a long way to go because this is our projected trajectory of implementing the SDGs, and this is what we need to do in order to do it. We know that we are not going to do it by 2030, but it's a very, very good guideline to move it forward. So, IFORIA, what our mission and vision is to develop the pathways, the dynamic and spatial pathways between where we are, what we measure here, this is where we are, and where we want to go, here. What we agreed and voted for as our policy targets. This is our work in IFORIA. So, today I want to, very quickly, this is where we work in terms of our thematics over the globe: climate neutrality and resilience. These are the different projects, and only in the gray areas we don't have explicit projects, but we have collaborators. And I will share the presentation because I don't have time to go through the sliders, but each and every project is identified there with the budget, with the consortium, with the focal points. Next, as I said, we work on water, food, energy nexus and land use interaction. Again, quite a lot over the globe with many projects, and all of our thematics are, at the end of the day, integrated. And I'm going to show how we integrate the climate neutrality transition with the water, food, energy system, climate neutrality and climate resilience transition, and how we integrate these two with seas and ocean sustainability, which is one other major element, how we use our seas and oceans and try to recover or sustain the ecological and ecosystem services resilience. Again, various projects, but I need to go very quickly. A lot on socioeconomic financial pathways and behavior economics. How do you finance the pathways? How you incentivize the implementation of the pathways in the market, outside the market, how you value externalities, how you integrate the value of natural capital into your decision-making processes, how people decide under ambiguity, uncertainty and ambiguity when you don't know the probabilities of the uncertain events. All these issues are main issues for us. And of course, a lot on innovation acceleration. It is important to us that all the innovations, technological, social, fiscal, financial, governance innovations are pushed as soon as possible into the market for massive deployment in order to really accelerate the transition to sustainability. And the last bit that we work a lot on is education and skills. In COP28 in Dubai, we presented a report that showcased that 85% of the skills and occupations that are needed in order to implement the already voted for and transposed into national laws European Green Deal framework. So what we have committed legally, each and every country in Europe, to implement by 2050, 85% of the skills and professions that are needed for this are not in the market yet, are not there. So even if you have the technology and the money and the solutions, you cannot implement it. You don't have the labor force for it. Okay, and various projects on this. I want to focus on this. This is the Global Climate Hub of SDSN that I'm chairing, and this is a holistic approach that brings together the different systems that we think are important for detailing pathways towards climate neutrality and climate resilience. So first we have an interdisciplinary mathematical modeling section, downscaling climate scenarios, scenarios for energy and transport use, scenarios for land use and marine use, health systems transformations, and then innovation transformations, and then embedding socioeconomic pathways into the integrated pathways of these systems. So at the end of the day, you integrate your derived pathways of each system that are integrated between the system into computable general equilibrium in order to see the effects on each sector of the economy, on the different economies, on trade, and identify how you're gonna finance the pathway and how you're gonna care for the vulnerable, those income groups, those countries, maybe in the global south, that cannot afford to pay for the transition. The second layer is the transdisciplinary layer. And for this, SDSN is very crucial because in each country of the world, we have a hub that brings together scientists with all other stakeholders, politicians, policymakers, businesses, financiers, and of course the civil society. So here we have participatory approaches that engage representatives from these different stakeholders in order to co-design the solution pathways so that the stakeholders own the solution pathways and want to implement. Unless they co-design and own and become shareholders of the solution pathways, they will never implement. We are working in about 120 countries now and finish the work for Europe, the Balkans, Southeast Asia, starting on China now and starting on Middle East and some countries in Latin America. The other important thing is that education is crucial. Why? Because in order to become a true engaged stakeholder in the designing of the pathways that are guided by science-driven approaches, which is the upper layer, you need to be aware of the basics. You need to have some education and knowledge and skill. So that part is also very important. And all of this is documented in the approach is already published, and papers on different countries are already published. The first thing was in Nature Sustainability, different publications in many other Nature portfolio journals. And the whole process is documented on this AI-ready digital platform with applications. All the data, geospatial, time series data, socioeconomic data, real-time data, all the models that we integrate, all the results presented in ways that stakeholders can engage. Visualization dashboards, decision support system, augmented reality, virtual reality, aided, result-based dashboards, again, digital twins for the different systems. And this is our suite, our modeling suite. And what I'm gonna show next is how we implement this modeling suite in one of the countries. And guess which country is that? It's my country, Greece. And let me say that we do this for each and every country in the world. And when this is finished, we engage with the stakeholders to refine and co-design, but also engage with the stakeholders when we actually set the initial models to see if the models make sense, if you explain to a stakeholder and discuss parameters, initial conditions, and so on. So the modeling suite of the Global Climate Hub starts from food and land use systems. There we use the Fable calculator, then goes to water requirements and land use requirements, then goes to energy and emission systems. Here we use LEAP, then the marine system, and then we integrate everything into computable general equilibrium. Fable and LEAP, we work on bigger consortiums that have developed this. We refine parts of it, but we don't own them. All other, the water requirements, the land requirements, the marine requirements, the general equilibrium models are of ours, the Global Climate Hub. And we start from the Fable inputs, we go to Fable output. I'm gonna explain each of these models very quickly. Then from these outputs, we inform the biofuel calculator, which we've also developed, then the LEAP input, then Fable and LEAP identify water requirements from agriculture, from the energy system, which is about all the different energy sectors, all the sectors in the economy and how they use energy. Then we also move from LEAP to energy requirements from maritime, and we build up the marine calculator. So what I'm gonna show you is an exercise that allows us to see the difference for Greece, but this is an exercise implemented at the moment in tens of countries. We move from the do-nothing scenario, the business as usual scenario, which assumes that the current trends continue by 2050, to the national climate neutrality commitment scenarios. This scenario assumes that the main sector of the economy become climate neutral. That is, our main policies are jointly implemented. And which are the main policies in Greece that are affecting the transition to climate neutrality? Well, obviously, the Greek National Energy and Climate Plan. I am part of the committee that puts that together. It's the Climate Change Committee at the Ministry of Energy and Environment. Then we have the Common Agricultural Policy as it was transposed in Greece. Then we have the regulations of EU ETS for shipping and the IMO's regulations, and also whatever is included in the National Energy and Climate Plan for shipping. Shipping is important for Greece. Greece is the biggest commercial power, is the biggest power of commercial shipping in the world. We have the biggest fleet of commercial ships, so that's why it was important to put that in place. And then we have the Water Framework Directive. So this is about management plans in river basins in order to sustain water, both groundwater and surface water and wetlands in each of the 14 river basins in Greece. So we look for an integrated implementation of these policies in the integrated systems approach that I showed before. So starting from food systems, we know that food systems are a root driver of biodiversity loss, land use conservation, and sustainable freshwater use and climate emissions, greenhouse gas emissions. Climate change is already threatening food supply and also ecosystems and biodiversity. And here we are looking to meet global targets for food security, biodiversity conservation, freshwater use, greenhouse gas emissions, and in order to do that, we need to develop food and land use policies for each country. First, we've done a survey of the different impact assessment models that have to do with land use and land use change and agriculture. And we have different impact assessment models, 24 of them as the main ones, with a different emphasis, some on agriculture, some on water, some on forestry, land use, climate, economics, demographics. 12 of them are widely used in agri-food yams, and it's a good starting point just to see what it is on the ground. With regards to what we do, is that we use, for a start, the FABLE calculator, which is a combination of efforts that is led by SDSN and IASA. And this calculator is basically a simulation accounting tool for land use, agriculture, both crop and livestock, food systems, forestry, bioenergy scenarios, and the target is to achieve climate neutrality, biodiversity conservation, food security, and you also introduce demographic assumptions in order to have the demographic dynamics. So it is a demand-based approach. It gives you billions of scenarios. What we use is data from FAO and Copernicus, and also data on crops, livestock, climate, and socioeconomics. And so let me restate, this is led by UNSDSN and IASA. We have 24 country teams. One of the teams is the Greek team that I lead. And how you start engaging with this calculator. First, you identify your national commitments. This is your policies with regards to land use and agriculture. Climate and biodiversity targets we have in Greece, the National Energy and Climate Plan, the Psaridis Committee report, which is a 10-year development report of the country that I co-authored with Psaridis. He is a Nobel Prize winner in economics. And then commitments that derive from the European Green Deal framework that I showed you before, all that have to do with Fit for 55, Common Agriculture Policy, EU Biodiversity Strategy, and then all proposed, in addition to the policy targets that are already there, we also have proposed data-driven national targets when we lack some targets in policy. So agriculture in Greece contributes 4% to national GDP, 11% to workforce. Challenges: low productivity, low adoption of technologies, aging workforce, low, small size of the parcels of agricultural land. We have the current trends: enhanced economic activity, high urbanization, no change in diet, 50% surge in key exports, afforestation, targets does not exist, post-harvest losses targets do not exist, and we have an RCP scenario of scenario 6, that is the scenario of high global emissions that peak at 2040. Now, here is where we want to go, to the national commitments. That is medium high-speed economic growth, shift to healthy diet, reduce agriculture import, increase in productivity, expansion of protected areas, a surge in organic and agroecological practices, and an RCP scenario of moderate global emissions that peak 2050 and then decline. And these are the first results from the food land use system using the FABLE calculation. In the national commitment scenario, we have agricultural emissions being cut by 50% by 2050 compared to the business as usual, which is achieved by reducing livestock emissions and increased land-based carbon withdrawals. With regards to the national commitment scenario increases agricultural productivity, improves climate mitigation, and improves competitiveness. With regards to cost, the national commitment scenarios reduces total agricultural cost, and mainly through reductions in pesticides and decline in fertilizers. And with regards to land use, we shrink pasture land by 78% and increase land categorized as other. So this is the land use scenario. Then we go to LEAP. I will take additional 3 minutes and I will finalize. Give me 3 minutes to finalize. LEAP brings together all the sectors and their energy demands, residential, industry, agriculture, transport services, and also energy supply, primary resources, secondary resources, transformation processes, and all the types of pollutants of greenhouse gas emissions. And we have a detailed representation of all sectors' energy uses. And when we run the model, including the results from FABLE into LEAP, that is energy requirements from the sectors that are included in LEAP, we have greenhouse gas emission reductions, we have renewable expansion, we have energy consumption that reduces total energy demand by 23%, and we also have an energy supply shift, which drops with regards to oil refining, and electricity production rises via hydrogen and synthetic fuels, and of course, sun and wind. And we've done this for the whole of Europe as well, and here you can see the optimal, the cost minimizing energy sources for each country, and also the energy corridors, who imports, who exports, and this is what happens with hydrogen in 2050. This is 2050 projections. And we also integrate biofuel model. This is important. We use FABLE calculator, and we identify eligible and available biofuel production. And this is important for Greece because currently imports for biofuel are crevasses, and we don't have any plans for biofuel production. This shows that we have a lot of potential for that. And we also integrate land use requirements. So for each energy source that takes space, biofuels, wind, solar, we calculate the land requirement and we embed in the land use that derives from the FABLE model. And we also do resilience, a lot by Tom on fires. This is downscale because resilience is more downscale than national, and it is important to understand the different systems. Climate change increases wildfires, air pollution and risk for human health. Burn sites also have hydrological processes being affected. And what we do for each fire, after we have the impact assessment, the atmospheric modeling, the hydraulic modeling, we design post-fire flood protection and soil erosion work. We have a paper in Nature Climate Action on the right steps, but also here we show that it's much more cost efficient to actually do the protection than not do it compared to the monetary impact of the wildfire. Also, water requirements are integrated based on crop, based on all water requirements from all sectors of the economy. And then we have a model for marine shipping that takes into account all the regulations, IMO, EU ETS, and then optimizes fleet side taking into account fleet capacity constraints, ship production constraints, fuel demand constraints, emission constraints, and regulations. And we have the effects of the different scenarios for the maritime. And at the end of the day, we give our recommendations to the government. And what is more important than showing all this modeling is that we end up saying that the creation of a unified platform for simulating complex systems, monitoring policy interaction, and targeting processes across all related policies can facilitate better decision-making, resource allocation, and long-term planning. And here we present a rotation of implementing the different policies that will get you to the target faster, with lower cost and lower dependency on imports. So any government will want to hear about this. And at the end of the day, we embed all of this in general equilibrium socioeconomic systems. These are computable general equilibrium that allow you to identify the effects on each different sector and define the blended finance, fiscal finance, and private finance that will allow you to actually implement the transition pathways. And one important thing here is that we also monetize. We have developed approaches and assessments that allow you to monetize ecosystem services so that they don't get ignored in budget allocations and investment decisions. Thank you for giving me the extra minutes. Thank you.
Thank you very much, Phoebe. And I really wanted to have you here because, as you see, she's really very active in the field and also in the science policy interface. And Siert has some comment.
Yeah, thanks for this presentation. It was very interesting to listen to you. Also in the context of our session yesterday on System Earth, environment, but also on the energy transition, and in particular in the context of the focus we had on renewable geoenergy, with active participation also of industry, and having the latest news on geothermal and on natural hydrogen harvesting. And of course, these topics are extremely important for Hungary, because Hungary is the hotspot on the continent of Europe. And I noticed in one of your slides where you were mentioning hydrogen, but I didn't see geothermal. And geothermal is really on the move.
It's part of the energy source. It must be there. Greece is also very active in geothermal.
Yeah.
It's part of our energy sources, and actually the Academy of Athens, which is our more prestigious institution, is mainly focused on geothermal potential in the green transition.
I'm very glad to hear this, because your immediate neighbor, Turkey, is also very much on the move, especially in Western Turkey.
Oh, yes, yes. And let me also say that on Tuesday, we are organizing a big conference in Athens on hydrogen. It's called Transforming Europe's Energy System, hydrogen as an enabler. And we have speakers from the Middle East, from the Western world, and I hope it can be made available on video. Yeah, hydrogen is very interesting.
Very brief.
Very brief comment. Thank you very much for your presentation. I just wonder how you integrate new knowledge. Like Germany didn't want to have, for instance, carbon capture and storage. Now they will. It's a complete change in the CO2 treatment. We have been focusing on biofuels. We have now detected that this is not a good idea. So all these changes are most relevant in, and we have believed in that green industries would help us, but we are now in the third year of recession in Germany, which has a major impact on our economic situation. So I'm also doing these kind of modelings, not as complicated as you do, but the challenge is how can you incorporate new knowledge in these kind of integrated modeling.
Indeed, this is the challenge, I agree, and we should talk more. But we are going to make this platform open access. So you are going to have the models, whichever are ours, that we own, but also, outputs from models that are not ours. For example, Leap and Table, we co-develop this, but we don't own them. And my model is a GTU model that we work with. I coordinate there the energy and climate section, so my model is our basic energy model. Now, I am hoping that as soon as this is open, and open access, that is, that we are going to have a whole community of researchers aiding in the incorporation of the new laws, the new technologies, the new ideas. And our work will be to say, okay, Germany now realizes that biofuel is not a good idea. Where do we go and change this in order to rerun these models, which are going to be very fast to rerun, not very fast, but fast to rerun with a good power computer, in order to recalculate everything. And the calculation exercises continues, because as you know, it's not just Germany, it's each country, and then it's the European Commission that every month, because I'm an advisor there as well, they have new law. And they want us to transform this international. So this has to be a very flexible, fast, easy to use, open access, and drive a big community of researchers to do exactly these recalculations of the time and have the direct link with policymakers to inform them if something is a good idea, bad idea, if something is doable, not doable, cost efficient, and all that. There's no other way to do it. But it's important to pinpoint, given that you know the integration of the model, where you need to go in order to intersect the new information.